Hello and welcome to this Haas tip of the day. So, many of us know that one of the easiest ways to crash a machine is to goof up on our tool length offsets or maybe our work offset Z values. So, today's tip is all about making sure that doesn't happen, right? We're going to show you how to manually set those tool length offsets and those work offset Z values. Hello and welcome to this Haas tip of the day. So, many of us know that one of the easiest ways to crash a machine is to goof up on our tool length offsets or maybe our work offset Z values. So, today's tip is all about making sure that doesn't happen, right? We're going to show you how to manually set those tool length offsets and those work offset Z values. So here's the part that we're setting up, right? You might have seen this part in such critically acclaimed YouTube videos as finding your edge and finding the center of the hole, right? We've got other videos you can see that help you set up the X and the Y work offsets. Again, on this part, our G54 work offset is the back left corner. On this one, our G55 work offset is the center of that hole. But in those videos, we never showed you how to set your Z values. That's what we're gonna do right now. I've already loaded up all the tools for this part, and we're gonna touch them off manually right now. I'm navigating to my work offset page, and I'm just making sure that there's no values in for my G54Z or my G55Z. We're starting from scratch here. Now, I do have XY values, but that's because we've already found our XY locations, right? Watch the other videos. Now I'm switching over to look at my tool offset page, and all my tool offsets are blank right now as well. So we're ready to start. I've got my tool on the spindle, and I'm going to jog right on top of this left block here. Now, why am I touching off on top of this left block? Because my programmer told me to. I've got a setup sheet here that shows the back left corner is my 0, and it also tells me to touch off on top of that part. So at this point, I'm going to show you guys how to touch off with paper. Now, there are lots of different methods. We're just going to show you this one first. With the tool on the spindle, I'm going to jog down right above the part, switch it into 0.001 jog increment. Then I'm going to jog down with a sheet of paper in between the part and the tool. I'm going to move down slowly, one click at a time, while pulling the paper back and forth. Now, as soon as I start to feel this paper drag, I know that the tool is pinching the part and it's where it should be. So I'm going to stop jogging at this point. I'm going to go to my tool offset page with tool offset 1 highlighted. I'm going to press the tool offset measure key, minus 18.488. That's my machine position. That's what it's using for its tool offset. We'll talk about that later. Okay, so I'm going to close my door and I'm going to press the next tool. We're going to repeat this process for all of our tools. Now, we've actually made a whole other video on how the next tool button works. So if you haven't ran through the next tool function before, watch the next tool video. This is my second tool, just a 1/2 inch end mill. Again, jogging above the part, little piece of paper. Once it pinches and stops moving, I'm done. Tool offset measure, next tool. Now, you can get a little bit better tool touch off, a little bit more accurate if you're on 1/10 of a thou increment. For me, if I'm touching off on paper, I'm not too worried about perfection. If I want to get a better touch off than paper, I'm going to grab a piece of shim stock. This shim right here is 4/1000 of an inch thick. I'm going to take this shim and touch off my tools. I'm going to set it underneath the tool, jog down above it, except this time I'm going to switch to 1/10 of a thou increment. I'm going to bring it down click by click while moving the shim back and forth until the shim starts to drag. I don't want to pinch my shim. I just want it to drag slightly. At that point, we'll press tool offset measure. Now, with this method, we're not done yet. We've got to subtract the thickness of this shim from our tool offset. So I have to type in minus 0.004 and press the enter key to subtract the thickness of that shim from that tool. Now, likewise, there's a whole bunch of different types of touch-off tools out there. This is one electronic touch-off tool. If this touch-off tool was placed on top of my part, and I jog down, and then just above the part, switch to 0.0001 increment, and I bring this thing down until this light turns on, then I press tool offset measure. This touch-off tool is 2 inches thick, so I'd have to subtract 2 inches from my tool offset measure value. Okay, so we've gone ahead and touched off all of my tools. I think this job had 7 or 8 tools in it. Now what I'd like to do is do a tool change to one of the pointier tools in my carousel. I think tool 6 is a drill. Okay, so I've got my tools somewhere above my G54 part. All my tool offsets are set. I've got tool 6 in the spindle. Now I'm going to enter into MDI, G54, G0, G90, X0, Y0, G43, H6, Z.1, and then an M30. So what we've done here is we've just essentially written a G-code program. This is amazing. If you don't know where to start when learning G-code, this is it right here. We're going to use work offset G54. G0 just means go really fast, rapid mode. G90 means make all of your moves in accordance to the G54. Now we've got an XY value on this line. We want this thing to move right to our X0, Y0. The next line says G43, H6, Z.1. These are the scary moves. When you're making a Z move on a machine, this is what you really have to watch, right? And that's why we're checking it before we run the real program. G43 just means it's going to use a positive tool length offset. Now this is one of the very few codes I don't explain much on, right? Because we always use a G43 in combination with our H value. Why H6? Because I've got tool 6 in the spindle, and I want my H value to match my tool value. Now 99 times out of 100, right, or more than that, our H value matches our tool offset. Z.1 means move to 0.1 inch in our work coordinate system. Then we end it all with an M30. Okay, before running this, we're just going to go ahead and go to our G54 page, and we're going to make sure that our Z value on our G54 is set to 0. I'm going to go into MDI, make sure I'm on 5% rapid, and I'm going to press single block. After this positions the tool in the XY, I'm going to press cycle start again. The tool's going to move down just above the part. I'm going to have my finger on feed hold to make sure I can stop that tool, somewhere just above the part. Now my work G54 position screen says I'm at Z.39 inches above the part. Does that look reasonable? It does. That could be about 0.4 inches above the part. At this point, I'm going to change my position screen to distance to go. If I press this cycle start, my Z is going to move minus 0.29 inches. Is it going to hit anything? It doesn't look like it. So we're pretty safe. So I'm going to press cycle start. That's it. Our tool ended up just above the back left corner of this stock, right where it should. More importantly, we're sitting about 0.1 inches above the part, visibly, right? We've just verified that our G54 Z value is set correctly, and we also verified that the tool offset, at least for tool 6, is set correctly as well. Right now, I'm going to put an indicator in the spindle, and we're going to set that G55 Z value. I'm going to jog down right above our part, pretty close to where we touched off the tools. And I want to jog down until my indicator reads 0. With our indicator resting on top of our part, right where we touched off our tools, that's the important part, I'm going to go to my position screen, and I'm going to move over to our operator column. And I'm going to press the origin button. What this did was it zeroed out my Z-axis operator column. Now you can do the same thing for your X and Y axis as well. We could have pressed X origin and zeroed out the X that way, Y origin and zeroed out our Y, but right now we just care about our Z. Now with my operator Z value and my indicator both reading 0, I'm going to jog up and out of the way and over above our G55 part. Once there, I'm going to jog back down until my indicator reads 0, 0 again. Okay, so my operator Z value now says minus 0.07 inches. So the top of our G55 part is 70 thousandths of an inch lower than where we touched off our tools, our G54. So we go to our offset page, go to our G55 work offset Z column, and we enter minus 0.07, enter. So our G55 Z value should now read minus 0.07, while our G54 value Z column reads 0. Because we touched off our tools here, there was no offset adjustment needed. I just want to mention that we could have used any type of indicator, really. We just zero it out on the point at which we touched off our tools, zero out our operator Z value, jog up and over to our next vice, in this case G55, find out that position. Now we know the distance between our second vice and our touch off point, and we enter that in as our work offset Z value. Now I'm going to swap out to a pointy drill. We're going to check this G55 Z work offset. I'm going to jog down to a safe distance above our part. Then we're going to go into MDI, change that G54 to a G55. I'm going to press single block, 5% rapid. I'm looking at my work position screen, and I'm going to press cycle start. So it's moving in the XY first, right above the hole. Again, if you need to learn how to pick up a hole, look at the pick up a hole video. Now I'm going to press cycle start again. And before it gets too close to the part, I'm going to press speed hold. Now my G55 position says Z.4631. Could that be 0.4631? Looks pretty good. We'll go ahead and take a look at our distance to go value, and it says that my Z distance to go is 0.3631. So if I press cycle start, it's going to move in the minus direction by 0.3631. That looks fine. So I'm going to press cycle start. Now looking at this drill above our part, I can see that my X and my Y are correct, and more importantly, we're sitting at 0.1 inches above the part. We verified that our tool length offsets and our work offset Z values are correct for both our G54 part, where we touched off the tools, and our G55 part. Well, we've accomplished what we set out to do. We've shown you how to manually set your tool length offsets. We've shown you how to set those work offset Z values. And most importantly, we've given you 2 lines of code that you can run in MDI to check your own work, right? Take the time right now, rewind this video, look at those 2 lines of code again. Watch it over and over until you understand them. Those 2 lines of code rest at the heart of G-code. Well, if you got something out of today's video, be sure to share this video with your friends. Comment, like, and most of all, subscribe. You don't want to miss what we've got coming up next. Thanks for letting us be a part of your success and for watching this Haas tip of the day.